I think he gave in 2001, which still applies today. And if you look at how devices are going to fail, you're trying to, on the positive side, work against the hemodynamic displacement force, as well as the fixation stabilization forces. And what works against you? Well, aortic degeneration, material fatigue, and morphologic changes. And that's as true today as it was then. So we knew that we needed to hold an endograft in place to resist the downward force on the graft. When the graft bifurcates, that force increases. When diameter decreases, that force increases. But you need different things depending on the aortic diameter, the aortic angulation, the amount of calcium, the amount of thrombus. We know from many, many years of work that the aortic altered anatomy of the neck increases the risk of late seal loss and early failure, both shape, length, diameter, calcium, and thrombus. And we know that that anatomy leads to the increased risk of migration of those devices. You know, you can see here both thrombus and calcium, and multiple publications have come out showing that the risk of migration increases as you add these things. As we tried to understand this, we early on tried to understand the pull-out force of both a surgical graft versus some of the early iterations of endografts, which the Zenith is the only one of these that still exists today. And we found that both suprarenal fixation and active fixation seem to have a really good role in the ability to increase the amount of newtons of force it took to displace an endograft from a cadaver aortic model. And you can see that multiple studies were done with all these iterations of devices trying to mimic what we might see in a surgical graft. But we oversized our grafts as one of those mechanisms, and we found that when you oversize grafts, the aorta tends to increase to within a millimeter or two of that size, and that dilatation can lead to risk of late failure, both of migration. This is another paper from Ellen Dillevue that looked at 4 US trials, and you can see that the patients in follow-up, that 4% had a type 1 endoleak with aortic neck dilatation. It was similar really in their study among all the grafts. And the next thing we looked at is, well, what about at the bottom? If we had better iliac fixation, can that matter? And when we had better iliac fixation with longer purchase into iliac arteries, that did provide some columnar support. This is with the Talent device, and you can see with better iliac fixation, the device did better. But we know that self-expanding stents tend to, against a unnormal healthy aorta, tend to lead to expansion of a wall. And so is that really the best? And our general mechanism over the last 20 some years has been to oversize our devices. We looked at Mark Schermerhorn's paper, and this always terrifies me. You look that at 8 years, still 5% of patients treated in the United States have aortic rupture when treated with an EVAR. So clearly, we've not solved this conundrum, and it happens with every device. So whether it was many years ago with an Ancure device, or an Aneurysm device, or a Cook device, whether it's an Ovation device, a Talent device, and a DIRT device, it happens with all of them. Our early experience was really biased by using almost exclusively the Cook device, and we used to use Palmaz stents all the time, and it was really advantageous for treating early type 1 endoleaks, but amazingly, as the device could accommodate and grow over time, it didn't lead to late endoleaks, but the Palmaz would generally then separate from the wall and really not lead to any late failures. So what did we try to do next? We tried to fill the sac, and this was the Nelix device that was originally bought and then sold, taken care of by Endologics, but we really found that it did seal the sac, but it had no active fixation, and loss of fixation was really the Achilles heel with the removal of this device from the market. The next iteration is, well, maybe we looked at the balloon expandable data from the original Palmaz series from Frank Feast's device, and you saw that you didn't really see growth. There were several iterations of devices in Europe that had balloon expandable fixation systems. They didn't see growth, and that led to the trivascular system and really lack of neck dilatation over time with using still barbs for active fixation. But that's not perfect. Many, many years ago, we saw the first iteration in 2008 describing the concept of stapling. The Aptus anchor was released. It was really part of a bifurcated endograft system, and it was its only fixation. However, that device had manufacturing issues with small limbs that weren't reproducible and had a lot of limb thrombosis, but that led to the Helifex anchor. With the Helifex anchor, you can see that depending on which device you do it in, it actually does increase the amount of fixation force and migration resistance, and then that increases with the number of anchors applied. And that's really, with all the aortic endografts at the time that were tested, with the exception of the Ovation device, because the sealing ring is not compatible. And what they found from the anchor registry is that adding those extra anchors actually works really good when used prophylactically. You saw sac regression in 47% of patients. And we know that sac regression is a really good surrogate for long-term success. And when you used it for a residual type 1A endoleak, it did actually help, but it wasn't perfect, and it was only, you still saw residual endoleak in the type 1A treatment arm of 20% of patients. But multiple studies then showed sac regression improved, and so really if we're treating the risk of rupture, and the risk of rupture is relative to the sac size, and the sac isn't growing and it's regressing, I think that's a keynote. We then know that if you use it in large necks, there is a benefit in large necks. Large necks are patients that are higher risk, and using the anchor device in wide necks actually helps. But the device isn't perfect. If there's calcium in the wall, thrombus in the wall, sometimes it's difficult to get the guide to oppose the wall, and there is a risk of embolization of those anchors. So what's out there, I am actually a consultant for them just to make sure in my disclosures. It's a nitinol suture. It has a biasing mesh with 4 preloaded sutures, and those sutures actually come out into the wall. You can see here's within a device, Zenith device that they've been deployed in. You can see the device in the early iterations below, and there's been about 11 first-in-human implants ongoing. This is a picture of the biasing mesh and the device as it comes out through the mesh. And really, it's trying to achieve the ability to get those devices in, to put them in specific places, but also then have less risk of embolization of those devices, and really trying to follow the same pathway for approval that we did for anchor, but also then to lead to better sac regression. There is one other company out there, Aorta Seal by Enduron Vascular Suturing. I did reach out to them, asked them if there was anything that I could share. They said right now they're too early in development, and so they asked me not to share any data. So I can just tell you that they're a company in development in Israel. The last thing that we've done and we've continued to work on is adding and developing up the aorta, both with fenestrated and branched devices, and the amount of force it takes to disclose a graft. Clearly, it goes up as you build up the aorta. But the downside of that is unless you get to healthy aorta, then you have increased risk because you have multiple branches now treated, multiple parts of the aorta treated. And so I would propose that for infrarenal aneurysms, I think that as we can improve our fixation locally and not extend up into the aorta, that is a better approach, and really leaving the branch and fenestrated devices for aneurysms that involve that part of the aorta. So in conclusion, 2024, hey, EVAR's here to stay. 80% of our patients are treated by EVAR. Self-expanding stents lead to neck dilatation. It is not always deleterious, but if we didn't have to have that, that would be advantageous. Aortic expansion, we know, is associated with increased cardiovascular risk, the risk of neck failure. Reintervention and rupture risk, unfortunately, still common at 8% in 5 years in the Medicare database. Branch technology in 2024, unfortunately, still not widely available, and device iteration fixation methods still need and are in development.